Hello, HEP students. Today we're going over the October 2018 Section 3 Math No Calculator section. This is Rob Jensen. I'll be kind of walking you through your solutions for today. All right, so let's go ahead and look through it. Problem number 1 that we have. And so what we see here is we see that we have a simple linear equation. We're solving for z here. So we want to move this piece over here to combine our like terms and then move this piece over here. And so now we have 2z minus z equals -1, and then you end up getting z equals -1, which gives me the answer choice of B here. So pretty straightforward and simple. All right, number 2, we see what we have here is we have a word problem that's being given to us, and then looking at the expressions, we're developing a linear equation. So it's a linear equation, and we're developing it. And so that means we're having to write one. Get that off. Sorry, not sure what's going on with that piece of things. I'm not sure how to. There we go. Just get rid of it, delete it. So we see that it is going to be in y equals mx plus b. So we're looking for the y, the m, and the b values here. So a television with a price of $300 is to be purchased with an initial payment of $60. So we can see $60. That's what we're having to pay. And weekly payments of $30. Which of the following equations can be used to find the number of weekly payments, W, required to complete the purchase, assuming there are no taxes or fees? So we want to see how many weeks it may take for this to happen. So we see, if we use to draw a graph, we can see X, which is weeks, and then Y, which is cost in dollars, and we should be going upwards to some degrees because we want to see as X gets bigger, the number of weeks, the more in which we pay for it. And so this gets bigger. So we see that there's initial payment of $60. So that means B and D are out. And then we're just trying to decide whether, you see that these things are the same. So is it going to be minus 60 or plus 60? Remember, it's going to get bigger of things. And we're going to start off with a payment of $60 here. So that means C is the answer choice and A is wrong on this one. Okay, let's look at number 3, what we have here. Number 3, we see that we have a table. And see, normally we're developing a function here. So this is one of those function table questions. And so we know this happens to be sort of these are the X values, and these are the Y values here, right? Nice. And so we want to then be able to see is what is, 1, the slope, and then 2, what is the intercept here? So what we can simply do, take the difference of these, which is going to be 5, so that's going to be my change in X there. And then take the difference of these, which is going to be, let's see, just less than, because 1694 add 5 is going to be 2194. So we can see this is going to be a difference that looks like 16, so add 1794, 1894, 1994. 2094, so that's 1, 2, 3, 4. So it looks like it's a difference of basically $5, almost $5, so $4.95. Yeah, so $4.95. So the change in Y is $4.95 here. Remember, our slope is going to be the change in Y over the change in X, right? So that's going to be $4.95 over 5. So that's going to express to us that it's going to be less than $1, right? So that means it cannot be C and D. So now we're just trying to figure out, well, what is the intercept of this thing? Well, if I'm at 5 pounds here, then I want to know what is it going to be if I'm now at 0 pounds here. So if it's at 0 pounds, and then I got to back this up by $4.95. So that's going to leave me with some value there, about $11. Well, guess what? There's that one. So A is the wrong answer choice for that one. All right, let's look at number 4 here, the things. And so number 4, what we can see is that we have a coordinate plane. We have a function that's being on a coordinate plane here. And it's asking us, and the line in the relationship xy plane above represents the relationship between the height, h of x, in feet, and the base diameter in x. We know this has to be x, right? Because x is down here, which is feet, and then y has to be the height, right? Doric columns and base diameter in x feet for cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base diameter of 5 feet? So again, base diameter is related to the x here. So 5 feet base diameter, so we see that is going to be right there. So we see that 5 feet base diameter is equivalent to 35 feet for the height. And the height of a Doric column that has a base diameter of 2 feet. Again, so we see that being right there. And so 2 feet is equivalent to, looks like going across is 14 feet. So the differential you see is going to be 21 feet, or C on that one. Okay. So let's look at number 5. We see this variable underneath the radical, so that's going to tell us that we're dealing with the radical equation. And if x is greater than 0, which the following is equivalent to the given expression? Actually, what we really have here is, so we can kind of split this out. My apologies, it's really not a radical. I mean, it kind of is, but really it looks like what we're dealing with here is we're dealing with a fractional exponent question here. So we're dealing with, again, a fractional exponent question. So one of the things we do is split this out, so we can kind of split that out. So that's going to be the square root of 9 times the square root of x squared. Square root of 9 is going to give you 3, right? And then the square root of x squared, or you can rewrite that as x, since that's going to be 2 over 2. And so that ends up being x. So the answer choice is going to be 3x, or answer choice A on this one. Okay, so looking at number 6 here, we see that we have variables that are in a fraction form. So this is going to be a rational equation. And what we see here is we see the equal sign here. So what that means is we're going to be cross multiplied and dividing of things. And there's something else too. I noticed that this x squared is also, that's a dot. That's something else I should be able to pick up on, that's a dot on top. So I can rewrite this expression as x plus 1 times x minus 1 over x minus 1 equals negative 2. And I'm just going to go ahead and write this over 1, because that's the same expression. Since we don't have a denominator over here, I'm going to go ahead and give it a denominator so we can either cross multiply and divide if necessary. So here, I can then eliminate these pieces. And so for that reason, then I'm now left with, because those cancel out, so I'm now left with x plus 1 equals negative 2. I go ahead and drop that piece. And then I can move that over. And for that reason, I'm now going to get x equals negative 3 and such. And so we can see that is the answer choice on this one. If you try to solve it out and cross multiply and dividing on this one, you certainly could. I mean, you could do that. So let me show you here. So let me just back it up and show you. You're going to get extraneous roots here. Okay, so and the reason is why I understand that I'm kind of going to extraneous roots is because I see that we have this x squared and this quadratic. And so whenever we have quadratics, when rational equations, we have to be very mindful of that. And so if I did do that, say I set it up like this, well, then you have negative 2 times x squared minus 1 equals x minus 1 of things. And so then I have to then carry that out of sorts. It makes it a little bit more complicated than what it really needs, because then you have x plus 1 times x minus 1 equals x minus 1 of sorts. Oh, get rid of that. So again, this kind of makes it a little bit more complicated than what it has to be. You can choose to divide by x minus 1 here, gets rid of that. Choose by x minus 1 here, so that gives you 1. So that then gives you negative 2 times x plus 1 equals 1, because 1 divided by itself is 1 of things. And then you've got to distribute of sorts and then move everything over. So you can see how this is more work than necessary and is required of you in this particular problem. So the other way is much, much easier if we can recognize that. All right, so number 7 here, we see that we have a function and we have a graph. So this is a function graph here. It's a function graphing problem. Okay. And so what this one is asking of us is the graph of y equals f of x is shown in the xy plane. What is the value of f of 0? Well, that's just telling me if x equals 0, then y equals what? So we can then see here, well, y then equals 4 when x equals 0. All right. Okay. So let's go through and look at number 8. So number 8 here, we're dealing with some angles. And so if we see this is 90 degrees, then we know that this whole thing has to be 90 degrees as well. Okay, if that's 90, then this needs to be 90, because we're talking about supplementary angles here. And then it says, in a figure above, point B lies on AD. What is the value of 3x? Well, we see that all of these being summed together equal 90. So 2x plus 2x plus x. So that's going to be 5x equals 90. Divide by 5. And so then you get x is equivalent to 18. Well, it wants to know what is the value of 3x. Well, 3 times x, which is 3 times 18, is going to have to be 54. Yeah, that's going to give me 54 degrees. So we see the answer choice is C. If you answer choice A, it's because you failed to recognize the curveball here. And make sure you are making note of those things there on that one. All right, let's look at number 9. It says, which of the following is an equation of the line in the xy plane? So this is basically a coordinate geometry graphing question. Okay, a graphing question, because we're trying to see how we plot this line and interpret it. Well, we know that they need to be in slope-intercept form, and one of the things we know is that we have a -4 intercept, so we know that b equals -4, and that we also know the slope is negative because of this downward. So here we have -y, and so we know that we're going to have to divide by and get rid of that -y, so this is a -4. So once I divide by that negative and divide that negative, that's going to make that a positive, so that eliminates that. Here I have a negative and I divide by that, so that's going to make that -4, so that checks out, so that piece checks, the intercept. Same thing here, we have, well, we divide by y, this is already a -4, so that's going to be good. And in here we have no negatives, so that's already a +4, so it's not going to be a -4. So that means that is wrong. So now we're looking between B and C. So if I write B out, I have x minus y equals 4. I then need to move this piece over here. So now I have the -y equals 4 minus x. And then divide by the -1. And so for what that's going to end up doing is in making this y equals, that's going to make that a positive x and a -4. So this piece is okay, but this piece is wrong, because we have a negative slope. So that makes B false, and so by default, C has to be the answer choice. Alrighty, so what we then need to see here, it says 10, we see we have a parabola, and we're kind of wanting, so we see this quadratic that we have. There's quadratics or parabolas, and it's kind of a graphing one here, and so we're trying to interpret this piece here. So if the graph of y equals 2x squared plus 10x plus 12 is shown, which that's what's above here, if the graph crosses the y-axis at point 0k, so that means that if x equals 0, then y is going to equal k. What is the value of k? Well, here, all we say is if we took 0, if x equals 0, and we put that into here and here, that's going to make these two pieces both zeros. And then what you're left with is positive 12, so the answer choice on this one is D. Okay. Okay, number 11 of things. Number 11. So what we're looking at on this one, we see we have an equation of a circle. We see that how they're set up, and our equation of a circle is always going to be x minus h squared plus y minus k squared equals r squared. And so which of the following is the equation of the circle? So we see we have a positive 5, positive 7. So that means we need to have a negative 5 and negative 7. Negative 5, negative 7 is good. Positive 5, positive 7 is not good. Negative 5, negative 7, so that's good. So these are out. So now we're just looking between A and C. Nice divide and conquer problem. And the radius is 2. So the radius is 2. It means 2 squared is going to give me 4. And so we see the answer choice is A and not C on this one. Okay, number 12, what we see here is that we have a trig ratio problem. Trig ratio. All right, and these are similar triangles, so that means that these legs are in ratio of each other. So this leg is in ratio of this one's in ratio of this one. Of course, this one is in ratio of this one of things. So it says in the figure above, triangle ABC is similar to the triangle DEF. What is the cosine of E? So the cosine of E is the same thing as the cosine of B. So if we do the cosine of B, which is going to be the adjacent over the hypotenuse, which is going to then tell me that's going to be 12 over 13, well then, cosine of E is going to be identical to that. So that means our answer choice is going to be B. Okay, for question number 13, we see that we have a quadratic equation here. And so we have a quadratic, and that we're really just solving for intercepts. That means we're having to factor this expression. We're having to factor this. And so it wants to know what is the distance between the two x-intercepts. So within that, let's write it down. So x squared plus 5x plus 4. And so we know that since this is positive, we know our factor is going to be 4 and 1. So now it's going to tell us it's going to be x plus 4 times x plus 1 equals 0. So really then x is going to equal negative 1 and negative 4. And so if you use to chart those, the distance between those three would be 3. The answer choice is C. Okay, and then here we see that we have a radical equation. This is actually a radical equation. We see the variable is this, the radicand and things. So one thing we can try to do is, if I try to square this, and I got to square this, and you see I'm going to get a quadratic, right? Because as I sort of work to fulfill this, and so that's going to give me possibly an extraneous root. So this is not the most effective way to go through this one. The most effective way, remember, is just to plug in numbers. And so since we got Roman numerals, so let's try one of these. And so we'll just try that x equals 1, right? And so that means that's going to make that's going to be the square root of 4 times 1 is going to be the square root of 4. And then we have where 1 minus 3. Well, if we do that, we end up going to getting that square root of 4 is going to be 2. And this is going to be negative 2. So that doesn't work. so we automatically know that, okay, A is not an option, C is not an option of things. And so it could be either B or D. So let's try the next one and see what's produced from that. So if X is 9, all right, so we now have, let's do the square root of 4 times 9 equals, which is 9 minus 3. And so that's going to be the square root. 4 times 9 is going to be 36, right? Equals, what's 6? And then that's going to give me 6 is equal to 6. That checks out. So we now know the answer choice is B and not D there. All right. And number 15, we see that we have these system of equations. So remember when we have these system of equations here. And we're solving for a constant. And so we have a constant in here. And it's also telling us that there is no solution. Now remember when we see this, this is essentially telling us that we have parallel lines, okay, or essentially same slopes, okay. And so we can take that into consideration. So let's take this first one. Let's take number 1 and put it in slope-intercept form. So we now have negative 3x, sorry, negative 3x plus y equals 6. Let's move this piece over here. So now we're left with y equals, which would essentially be 3x plus 6. So we see the slope on this one is going to be 3 here. Okay. And if we take the second equation now, same thing, we now have ax plus 2y equals 4. Let's move this piece over here. So now we have 2y equals 4 minus ax, and we want to divide by 2. And so we end up with a final expression here, slope-intercept form is going to be 2 minus, which will essentially be a over 2x. Okay. So we see the slope on this one is going to be negative a over 2 of things. So remember when we talked about is we need to set these equivalent to each other because they're proportionate. Since the slopes are the same, that means the slopes, since there's no solution, means there's the same slope, so that means these slopes are proportionate to each other. So we can now write, say, 3 over 1 is equivalent to negative a over 2. And so we want to cross multiply and divide these. So now we get 1 times negative a is going to give me negative a. It's not a very good a. Let's try that again. It's more like a 9. So it's going to be negative a. 3 times 2 is going to give me 6. So therefore a equals negative 6 as we move that over. So the answer choice on number 15 is going to be A. And so remember, just on these, they're really not that challenging. And there's plenty of examples that are in the curriculum and in the homework to practice these, very well and understand exactly how to approach these when you so happen to see these problems. Okay, number 16. What we're looking at here on this one is we see a linear equation has been given to us, and we remember on these we want to match up the units to the equation. So here it says manufacturer shipped units of certain product to 2 locations. The equation above shows a total shipping cost, which is T, in dollars. So that's the total shipping cost. And then from there, it says for shipping C units to the closer location and shipping F units to the further location. So we see C is for closer, F is for far. If the total shipping cost was $47,000. Actually, let me do that in a different color. So we see the total shipping cost, which was indicated there. So that's going to be our T right here. So now we know T equals 47,000. And 3,000 is shipped to the furthest one. So So 3,000 units shipped to the further location. How many units were shipped to the closer location? So now we know that F equals 3,000. So here's our expression. We got F, we got T, we're solving for C here. So let's write it out. So we see that 47,000 equals 5C plus 12 times 3,000. So this is kind of what may trip up some of you guys with the math. So you want to be very careful because this is a problem you should not miss. Okay, so 5C, 12 times 3,000, 12 times 3 going to give me 36. And then add the 3 zeros. And then I want to subtract that. So 47 minus 36. Let's see, that means minus 36. So that's going to give us 11,000 equal to 5C. So if you need to, one of the things you can do is you can do long division. You kind of need to do that. 5 goes into 11, goes into it twice. So that's going to be 10. 1, 0. So that's 5 is going to go into 10 twice. And so that's going to be 10. And then you get 0. So then you get the last 2 zeros. So you can see the answer choice on this one would be 2,200. Okay. All right, let's look at number 17. This is an absolute value question. It's asking if A and B are the solutions to the equation above, what is the value of A minus B? So we need to set up two equations. So we can set up as 2x plus 1 equals 5. And then set up the other one as 2x plus 1 equals negative 5. So let's solve for these. So move that over. So it's going to be a minus 1 there. I'm going to get 2x equals 4, so x here is equal to 2. We'll just call this as A. And then looking at this one, and it says, and then with the next one, we move this one over, so that's going to be minus 1. So that's going to be 2x equals negative 6, divided by 2, and you're going to get x equals negative 3, which we'll say that is B. And so A minus B, so A minus B, we'll do the absolute values of that. So that's going to be the absolute value of 2 minus negative 3. So then that's going to give me 2 plus 3 is the absolute value, and which is going to give me the answer choice of 5. And so number 17 is 5. All right. So let's look at number 18 here. Number 18, it says Juan purchased an antique that had a value of $200 at the time of purchase. Each year, the value of the antique is estimated to increase 10% over its value the previous year. The estimated value of the antique in dollars 2 years after its purchase can be represented by the equation of 200A, where A is a constant. What is the value of A? Well, what we understand and should be able to pick up on this is that this is an exponential function question. And remember, the formatting of this is y equals ax to the b power. And so we see that if the expression of 2a, where a is a constant of that value, and we see that it's increasing by 10%, all right, well, then that should be where the a is equivalent to, I'm sorry, a in this expression, not the a here. That's a little confusing, but the a here should be 200. That goes here. So what we're really looking for is the x. And x, which is a in this particular problem of things. So we want to know what is the estimated value of the antique in dollars 2 years. Estimated value of the antique in dollars 2 years after the purchase can be represented by the expression. Okay, let me kind of back up for a second on this one. So we know that the A here is 200, okay, of the original principal amount. So what's really talking about the A here on this piece and this is a little bit, this is what the SAT likes to use similar variables differently in an expression and such. So really this A is, this X, really what we're looking at is this XB. That's the value that we're trying to calculate on this one, is the XB. So really the XB equals the A in this piece right here, okay? Which we would write the expression, since it's increasing by 10%, it would be 1.1. However, it's for 2 years, and so it's increasing each year by that amount, so then the term is 2. So if you square that, 1.1 squared is going to give me a value of 1.21. So really, the expression in its whole should be written as y equals 200 times 1.1. Oops, sorry. I'm not sure why I wrote that. 1.1 squared, which this is equivalent to this, the things. All right. So kind of, it's really not that tricky, but you just kind of have to be mindful of parsing everything out and how you're going to be able to solve for it, and understanding that the A here is really talking about the X, which is percentage, and the B is a term. That's really what it's always asking about. Okay, so here we see we have a special value systems. We see that we got this pattern of 5x plus 5y. So remember, always what I like to do is sort of add these terms together. And so I can see that, okay, well, 5x plus 5y is equivalent to 2,500. And there's my answer choice. Easy as that. Okay. Easy as that on that one. So don't make it more difficult than what it has to be. And then lastly, number 20 on this section, what we should hopefully notice is that by looking at this right here is a difference of the square or dots. Okay. Remember, the SAT loves embedding these into questions. So we can rewrite that whole expression as u minus t times u plus t, it's not a very good t, times u minus t. And we see u plus t is equal to 5, u minus t is equal to 2. So we can start inserting these values here. So essentially we have 2 times 5 times 2. And so if we do that collected together, that's 10, 10 minus 2. And so you get an answer choice of 20. Well, thank you so much. I hope you learned a great deal through this lesson and going over these answer choices. If you have any additional questions, feel free to get in touch with us and we can help you kind of further elaborate on any of the explanations that maybe were not as clear to you in our discussion with them. So thank you so much, and see you next time.